So what you're going to see on the screen is an example of a circuit that has things that are both in series and in parallel. It also gets a little bit tricky because you'll see that you're given some information about voltage, some information about current, and some information about resistance. So the question is, how do you even start to solve this circuit? Well, the first thing I do is I take a minute and I color code my pathways. So I'm going to say my inner pathway is red. My middle pathway is going to be green. And I'm going to say my outer pathway is yellow. Now I do this because I find it's much easier to visualize the current and all the pathways it's on if I've got a pathway like this. So now what I want you to do is hit pause and go ahead and try the question on your own. When you're ready, I'll start to take it up. At this point, I'll assume you unpause the video and you want to see the answer. Let's see what we can start to figure out. So in this particular case, we can see that my red pathway represents 0.2 amps of current. I can see that over here, my green and yellow pathways combined are equaling to 0.3 amps of current. So therefore, if I was to combine all those colors together, I would have 0.5 amps of current. Now, where are all three colors? Well, I can see that all three colors are going through my power source, and I can see that all three colors are going through resistor number 1 here. So now let's take a look. We've got 0.3 amps of current here, and it splits off and either goes down or it goes across. So now if we focus on just the green pathway, we know current has to be the same in series. So both of the resistors here have to have a current of 0.2 amps. Now if green and yellow combined are 0.3 amps, and green by itself is 0.2 amps, this is going to have 0.1 amps. We now have the current for every spot here on the circuit. And you might be sitting there thinking, I'm stuck. What you can do at any time is if you've got a resistor with two pieces of information, you can use R is equal to V divided by I, so Ohm's law, and start to figure out a missing piece of information. So in this particular case, I know I have a resistance of 90, I have a voltage that's unknown, and I have a current of 0.1. So I can rearrange that and figure out that my voltage here is going to be 9 volts. Let's take a look at that. So between here and here, between these two spots, I know the yellow electron is spending 9 volts of voltage. That happens to be in parallel with this green pathway right here. The difference is the green pathway is spent over 2 resistors instead of 1. So therefore, both of these resistors together have to equal 9 volts. So therefore, the second resistor has to have a voltage of 3 volts. Let's take a look at just this inner pathway, the pathway that my red electrons go on. My red electrons have 12 volts. They go up, they spend 2 volts here, they go down here to an unknown resistor, and then they come back up. So therefore, because they're only going to the 2 resistors, they have 12 volts to spend between the 2 spots. So therefore, they're going to spend 10 volts at this spot right here. Let's look at the yellow pathway. The yellow pathway is going to go through 3 resistors. It's going to go through the resistor here, and the resistor here. Now, if it's visiting those 3 resistors, we know the voltage needs to add up. So if we're spending 2 volts at the first resistor, an unknown amount at the second resistor, and 9 volts at the third resistor, therefore we have to spend 1 volt at that middle resistor. Now, does this all work out? Let's look at the green pathway. The green pathway is going to go through 4 resistors. It's going to spend 2 volts here, 1 volt here, we're up to 3 volts, 6 volts here, we're up to 9 volts, and then another 3 volts here, we're up to 12 volts. You'll see that every single pathway has worked out. So the last thing for us to do is to figure out the resistance at every spot. So in this case, R is 6 divided by 0.2, and that's going to equal 30 ohms. Resistance here is 3 divided by 0.2, so it's going to be 15 ohms. Resistance here is 10 divided by 0.2, which is 50 ohms. We have resistance here being 1 divided by 0.3, which is equal to 3.33 ohms. Resistance here is 2 divided by 0.5, which is 4 ohms. And lastly, R is equal to 12 divided by 0.5, which is 24 ohms.